Hello everyone, I am Mouliraj, Assistant Professor, Department of Computer Science and Engineering, Sri Shanmuga College of Engineering and Technology, Salem. Today we have see about graph traversal algorithms. What is mean by graph traversal? The method of examining the nodes and edges of the graph are known as traversing a graph. There are two standard methods of graph traversal methods. Wow. First one BFS, second one DFS. What is mean by BFS? BFS means breadth first search. What is mean by DFS? DFS means depth first search. We have detailed about breadth first search. Breadth first search use a queue as an auxiliary data structure to store nodes for further processing. Breadth first search we have used queue implementation. What is mean by queue? Queue is a first in first out. Next we have move to depth first search. What is mean by depth first search? Use a stack implementation, but both these algorithm use a variable status. What is mean by stack? Stack is a last in first out. We have detailed explanation about a breadth first search algorithm. What is mean by BFS? BFS is a graph search algorithm that begins at the root node and explore all the neighbor nodes. Then for each of these nearest nodes, the algorithm explore their unexplored neighbors, unexplored neighbor nodes and so on until it finds the goal. This is the example diagram of breadth first search. Breadth first search means you have searched the node breadthwise. Breadthwise means this is the example graph, and this is a graph is implemented to tree structure, and the input and output is maintained in queue implementation. This is the undirected graph. Undirected graph means the zero is connected to 1 and 1 is connected to 5. We have not used in the arrow marks, so we have choose any node and any directions. You have point out the root node. So I have choose the 0 is the root node. I have choose the 0. Also simultaneously we have tree implementation also. This is the breadth first search. So breadthwise we have search and implement the input output in the queue implementation. First is the 0 is the root node. 0 neighbor is 1 and 3. 1 neighbor is 5 6 5 6 2 3. Okay, and then 3 neighbor is 1 2 4. This is the diagram, and this is the example diagram. I have implemented in tree structure. Some difference we have applied. 0 neighbor is 1 and 3. I have implemented 0 is the root node and neighbor is 1 and 3. Next we have moved to 1. 1 neighbor is 5 6 2 3. The 3 is already visited, so I have take the 2 5 and 6. I have applied 1 neighbor is 2 5 6. Next we have moved to 3. 3 neighbor is 1 2 4. 1 and 2 is already visited, so 1 and 2 is skipped. We have directly moved to 4. So 3 neighbor is 4, and also simultaneously we have moved to queue implementation. This is the tree structure we have implement. First we have choose 0, next 1. 0 neighbor is 1 and 3, and 1 neighbor is 2 5 6, and 3 neighbor is 4. The queue implementation is first in first out. So the output is 0 1 3 2 5 6 4. The first value is 0, and second is 1, third one 3, fourth one 2, fifth one 5, and sixth one 6, seventh one 4. This is the diagram for breadth first search. This is the explanation of BFS. We start examining the node 0, and then all neighbors of 0 are examined. In the next step, we examine the neighbors of 1 and so on. This means that we need to track the neighbors of the node and guarantee that every node in the graph is processed and no node is processed more than once. This is accomplished by using a queue. What is queue? Queue is the first in first out. The queue that will hold the nodes that are waiting for further processing. Some applications we have used. What are the applications used in BFS? BFS means breadth first search. First one, finding all connected components in graph G. Second point, finding the shortest path between two nodes u comma v. of an unweighted graph or weighted graph. Next, we have moved to depth first search algorithm. Depth first search algorithms. What is mean by depth first search algorithm? The DFS algorithm progress by exploring the starting node of G and then going deeper to deeper until the goal node is founded or until a node that has no children is encountered. When a dead end is reached, the algorithm backtracks, returning to the most recent node that has not been completely explored. This is the example diagram of DFS. DFS means the DFS keyword is deeper to deeper, and also the backtracking method used in this implementation. We have connected to 0 to 1 and 1 to 3, 3 to 2, 2 to 4 and 4 to 6. The 5 is missing. I have visited 0 to 6, 0 to 1, 1 to 3, 3 to 2, 2 to 4, 4 to 6. This is a tree implementation. I have missing the node 5. So I have reached the 5. How to reach the 5? I have used backtracking method. We have used and reach the 5 nodes. We have used in backtracking method. The last node is 6. The backtracking method implemented in this step. 6 is backtracked to 4 and 4 is backtracking to 2. The 2 is connected to 5. So I have implemented in also simultaneously the tree is also 2 is reached to 5. I have backtracking 6 to 4, 4 to 2 and 2 to 5. I have reached the 5 nodes. And also the stack implementation is used. The stack implementation means last in first node. The last node is 5 and 5 we have moved to 6, 6 to 4 and 4 to 2, 2 to 3, 3 to 1, 1 to 0. This is the output of stack implementation. Next, in this algorithm, edges that lead to a new vertexes are called discovery edges, and edges that lead to an already visited vertex are called back edges. This is the difference between DFS and BFS. DFS means the depth first search, BFS means breadth first search. DFS is backtracking is possible from a dead end. Backtracking is not possible in BFS. The DFS vertices from which exploration is incomplete and processed in a LIFO order. LIFO order means last in first out. The BFS, the vertices to explore the organized as before FIFO. FIFO means first in first out. The queue implementation used in BFS. Next, DFS search is done in one particular direction, but the BFS is the vertices in the same level are maintained in parallel, left to right. This is the difference between DFS and BFS. Today we have covered the DFS and BFS topics. Thank you.